little bit, just so we can write down and remember what we saw. We needed to think about amorphous versus crystalline solids. Okay, so in the video that we watched, which was really great from Ted, it mostly talked about amorphous solids. And we just really need the definitions for our purposes. Amorphous solids have no crystalline structure. So it's a little bit more random at the atomic level of an amorphous solid. They don't have those jagged edges like a crystal solid. So in the video they gave you the example of glass. What are some other things that are kind of like glass? And this might not make sense, but rubber. Like, think about a car tire or the eraser on your pencil. It does not have a crystalline structure. It is not sharp and rigid. It is flexible. Okay? It is kind of looks like a liquid that's gotten solid somehow. And that's what you want to think about with an amorphous solid. If it's real smooth, no sharp edges, a gel is an amorphous solid. Alright, so a couple of other things as no distinct melting point. Now that is a weird thing to say, but as an amorphous solid, as these things like sand heats up, slowly melts across different temperatures, and then it can cool down. So you can get it really, really, really hot and we're still melting, or it can start to melt at a lower temperature too. Also, you need to know that, and let's think about this. Which one has weaker intermolecular forces? An amorphous solid with no crystalline structure, or an ordered repeating pattern? The amorphous solids have the weaker intermolecular forces. Alright, and that's all you really need to keep in your head for that. Crystalline solids, they have an orderly repeating pattern. They have an orderly repeating pattern. It's kind of similar to, or it reflects from, the bond angles that we learned earlier. Remember, we talked about trigonal planar and a bent and a linear pattern. Well, these crystalline solids, that pattern comes from the bond angles within their structure. And there are 7 structures that we need to kind of think about. And in your lesson on Canvas, let me just pull this away. In your lesson on Canvas, this diagram is way better. All that I really want for you to think about writing down is just the names of them. And you can see those angles, that degree angle. Cubic has 90-degree angles. Tetragonal has 90-degree angles, so a little longer. Orthombic has 90-degree angles. So, and honestly, tetragonal and orthombic, very similar. Okay. Monoclinic has a 90-degree angle, but it also has that tilt. Okay. Rhombohedral, so we know that's a rhombus, that comes from the rhombus root. And triclinic, hexagonal, has this 120-degree angle included in it. So if you just write the name and the angles that are included in it, then that's all you need to have for your notes. But it's way easier to see the pictures and examples in the data table here in your lesson. So I'm going to go ahead and list mine in my notes, and then we'll move on to the CK12 work for today.